Here we go, the review sheet for our test on exponentials and logarithms. You can feel free to skip through this to whatever question you feel like you need help with, but I'm going to work through all of them. First, find the equation of the line tangent to the natural log of x squared at 2, 4. Anytime you need the equation of a line, you need two things. You need a point and you need a slope. We already have the point right here, and we know in calculus we find the slope by taking the derivative. So our initial equation is the natural log of x squared. The derivative of that would be the derivative of the inside over the inside. Now if you want, you can go and simplify that by canceling out one of the x's. And we need to plug our x value in right here. So we get that the slope is 1, because the derivative at x equals 2 is equal to 1. So now we have the point, which is circled, and the slope right here, which is 1. I'm going to use the point slope form. Sorry, it should just be y minus y1. So y minus our y value, which is 4, equals our slope, 1, times x minus the x value, which is 2. You can leave the answer like that if you want, or you can solve for y by just adding the 4 over to the other side and getting y equals x plus 2. Next up, we're told to differentiate, meaning take the derivative of e to the 4x times x cubed. We will need the product rule for that. Our f will be e to the 4x. The derivative of that will be itself times the derivative of the exponent. G will be x cubed. G prime will be the derivative of that, 3x squared. So we do f prime, which I'm going to write as 4e to the 4x times g, x cubed, plus f times g prime, so I'll write it as 3x squared e to the 4x. Then on number 3, we're told to evaluate an integral. So I'm going to choose to use u substitution. I'm going to make u equal to the exponent, x squared plus 2x. Remember, in general, when you're doing integrals with e, if there's just one e, you want to use the exponent as your u. If there's more than one e, you'll usually use a whole e from either inside of a power, a radical, or denominator for your u. But here there's just one, so we'll use the exponent. The derivative of that is 2x plus 2 dx. So we've got to figure out how we can change that so it will match the x plus 1 dx. To do that, we divide both sides by 2. And we have a good match. So we can plug this in. It'll be 1/2 integral of e to the u du. And one of the easiest integral rules there is, the integral of e to the u du is e to the u plus c. So our final answer is 1/2 e to the x squared plus 2x plus c. Moving down. Number 4, we're told to take the derivative. It'd be best to go ahead and rewrite this first using the properties of logs. We can change that dividing into two logarithms being subtracted from each other. So now I take the derivative. I do the derivative of the inside over the inside. Same on the next piece, I do the derivative of the inside over the inside. And that's the derivative. On number 5, we're told to take the derivative of an e function, of an exponential. I'm going to start just by rewriting that as e raised to 6x to the negative 2. The derivative of an exponential is itself times the derivative of the exponent, which would be negative 12x to the negative 3. So we've got to multiply negative 2 times 6 and then subtract 1 from the exponent. You can leave the answer like that, but just keep in mind, for the sake of multiple choice, they could bring the negative 12 out front, put the x squared back on the bottom, and this x to the negative 3 could be moved to the bottom as x cubed. So this answer is completely fine on open-ended, nothing wrong with it at all, but for the sake of multiple choice, keep in mind that that is also the same thing. Number 6, find the integral. We're going to go with u substitution. When there's a denominator, that's generally the right choice for u. So u will be x cubed minus 5. The derivative of that will be 3x squared dx. To match the x squared dx we have right there, we'll divide both sides by 3. So now we can substitute. We get 1/3 integral of du over u. So that is 1/3 natural log of the absolute value of u plus c, giving us a final answer of 1/3 natural log of the absolute value of x cubed minus 5 plus c. Next up, 7, 8, 9. 7, we're finding the derivative. So I'm going to use the properties to rewrite. First of all, we know the fourth root is the same thing as a power of 1/4. And the properties allow me to rewrite that still on the original equation, is bring that 1/4 out front like that. So I have not taken any derivative yet. I've just been using the properties of logarithms to rewrite it. Now for the derivative, I'll leave the 1/4 out front, and I'll do the derivative of the inside over the inside. You could multiply those together if you wanted, but I would honestly just prefer it left like that. But I mean, it's true also if you want to do 1 times the top and 4 times the bottom, and that's still a correct answer. So either one of those would be good. Okay, number 8, we're using the properties of logs. Notice, no derivative, just the properties. I would recommend starting by separating the multiplying and dividing into adding and subtracting. So first I'll have the natural log of sine x, and I was multiplying that right here by the square root. So I'll add the natural log of 4x squared minus 3 raised to the 1/2. I am rewriting the square root as a power of 1/2. And then I was dividing x plus 5 to the 7th, so I'll subtract natural log of x plus 5 to the 7th. My last step is then to take the exponents and move them down front as coefficients. So natural log of sine of x doesn't change, but I do have plus 1/2 natural log of 4x squared minus 3 minus 7 times the natural log of x plus 5. I know I wrote that kind of small, so I'll pause there. Next up, we're doing it same properties but in the opposite direction. So I'm going to start by taking the coefficients and moving them up as exponents. We get natural log of x squared, natural log of x cubed minus 4x to the 1/3. You could also write that as a cube root if you wanted to, and the natural log of x squared plus 4 to the 1/2. You could also move that up or change that to the square root if you wanted. Okay, then the first two we're adding together, so when we combine them into one logarithm, we need to multiply them. So x squared times x cubed minus 4x to the 1/2. Then we're subtracting the third piece, so we divide by x squared plus 4 to the 1/2. Sorry, I should have a 1/3 on one of those up top there. X cubed minus 4x to the 1/3. Last one, number 10. Find the slope of the tangent line to the graph y equals natural log of x squared at the point where x equals x squared, e squared. Notice we're not asked to find the equation of a tangent line. We're just asked to find the slope. Well, the slope of the tangent line is the derivative. So while they may be using different math language here, they're really just saying what is the value of the derivative of this equation at e squared. So we'll start by finding the derivative. So y prime will equal the derivative of the inside over the inside. I'll go ahead and reduce that to 2 over x squared. And their question is, what would the derivative be at e squared? So I just plug e squared in for the x. So I get 2 over e to the 4th. And you can leave the answer like that, or if you want to type that in your calculator and get the decimal equivalent, that's fine as well. Good luck on this test. Make sure you know those rules, and I know you will do great.